Hello students. So today I am doing class for class 12 science. The topic is the same topic that we were doing in the last online class, that is the first order derivative. So this is the continuation class. Same exercise 3A, page number 294. Each question carries 5 marks. So in the last online class we did question number 5, right? So let's do question number 6. If y is equal to, a fraction is given there, 1 plus sine theta plus cos theta divided by 1 plus sine theta minus cos theta, so that dy by dx plus 1 upon 1 minus cos theta is equal to 0. So from this given you have to prove the value for dy by dx, that is dy by dx plus 1 upon 1 minus cos theta is equal to 0. So it should be dy by d theta, not dy by dx. It should be dy by d theta, right? Right. So it is dy by d theta. Because right hand side is expressed in terms of theta, so it should be dy by d theta. Okay? So let us prove it from given. Okay? So from given, we write y is equal to 1 plus sine theta plus cos theta divided by 1 plus sine theta minus cos theta. Okay? Don't differentiate it directly. So if you can use the formula from trigonometry, use that formula. Okay? So now 1 plus cos theta, there is a formula 2 cos square theta by 2. You know that formula, isn't it? That is 1 plus cos theta is equal to, what is the formula? It is 2 cos square theta by 2, right? Again 1 minus cos theta is there. There is formula for 1 minus cos theta which is equal to, it is 2 sine square theta by 2. So you can use this formula. Again you can use the formula for sine theta also in some multiple angle. So sine theta is equal to, what is it? It is 2 sine theta by 2 cos theta by 2. So these are the formula from submultiple angle in trigonometry. That is 1 plus cos theta is 2 cos square theta by 2, 1 minus cos theta is 2 sine square theta by 2, and sine theta is equal to 2 sine theta by 2 cos theta by 2. Okay? So let us use the formula here. So y is equal to, let us write it together, 1 plus cos theta, keep it within bracket, 1 plus cos theta plus sine theta divided by, in the denominator, 1 minus cos theta within bracket plus sine theta. Okay? Or y is equal to, let us use the formula now. We have just written out there 1 plus cos theta. What is 1 plus cos theta? It is 2 cos square theta by 2 plus, what is sine theta? It is 2 sine theta by 2 cos theta by 2. This whole divided by, what is that 1 minus cos theta? It is 2 sine square theta by 2 plus, what is the formula for sine theta? It is 2 sine theta by 2 cos theta by 2. Is that clear now? So let us simplify it now. Or y is equal to, now let's simplify both numerator as well as denominator. Now what is common in the numerator? It is 2 cos theta by 2, isn't it? It is 2 cos theta by 2 is taken common. So within bracket, what do we get? 2 cos theta by 2 is common out here. So within bracket we have cos theta by 2. Cos theta by 2 plus sine theta by 2. Whole divided by. In the denominator also, what is common here? It is 2 sine theta by 2. This is common, right? So within bracket, what do we have? It is sine theta by 2 plus 2 sine theta by 2 is taken common, so it remains cos theta by 2 only. So it is cos theta by 2. Okay? So you can cancel these two factors out here. You can cancel them. Here also 2 gets cancels, right? So or y is equal to, what is that? What is cos theta by 2 divided by sine theta by 2? It is cot theta by 2. So I think you have understood it. Now let us differentiate it with respect to theta. Now we have to prove dy by d theta plus 1 upon 1 minus cos theta is equal to 0. Okay. So write down differentiating both the sides. Differentiating both the sides with respect to theta. Okay. So therefore dy by d theta. We are differentiating both the sides with respect to theta. So dy by d theta is equal to cot theta by 2. Cot theta by 2 is there. Let us take it as cot theta. What is the differentiation of cot theta with respect to theta? It is minus cosec square theta. But here it is cosec square theta by 2 into. Again you have to differentiate the term which is assumed as theta there. That is theta by 2 was assumed as theta. Now differentiate theta by 2 with respect to theta. So what do we get? Half is constant into d by d theta of theta is always 1. Okay. So it is minus cosec square theta by 2 into half. Right. Now let us simplify it again. Or dy by d theta is equal to minus, this is your 1 upon sine square theta by 2 into half. Okay. Or dy by d theta is equal to minus 1 upon, this is your 2 sine square theta by 2. So what is the formula for 2 sine square theta by 2? This is from sum of an angle. Just now we did that formula, isn't it? What is the formula for 2 sine square theta by 2? It is 1 minus cos theta. So or dy by d theta is equal to minus, this is 1 minus cos theta. So 2 sine square theta by 2 is 1 minus cos theta. So take it to the left hand side, you will get the answer, isn't it? So dy by d theta then plus 1 upon 1 minus cos theta, which is equal to 0. That is proved. Understood? So you can copy it. Now do the next question now. So now we'll do the next question, that is question number 7. If tan y is equal to tan x plus sec x minus 1 divided by tan x minus sec x plus 1, prove that dy by dx is equal to 1 upon 2. Okay. So now in this case you have to simplify the given expression, then only you can then you can only get the value for dy by dx as half. That is, you will get the simplified value of dy by dx is equal to half, right? So now let us simplify the given part. That is, here given is tan y is equal to tan x plus sec x minus 1 divided by tan x minus sec x plus 1. Now let us simplify it further. You know tan x and sec x, you can write it in terms of sine and cos. So let us write it in terms of sine and cos. So tan y is equal to, what is tan x? It is sine x by cos x. What is sec x? 1 by cos x minus 1 whole divided by, what is tan x now? It is sine x by cos x minus 1 by cos x, and this is plus 1. Is that clear? Now you can get the LCM in both the numerator as well as in the denominator. So tan y is equal to, what's the LCM in the numerator? In the numerator cos x is the LCM. So what will be there in the numerator here now? It is sin x plus 1 minus cos x. And here also what's the LCM? That is cos x. So what will be all of this denominator? Here cos x is the LCM. The expression will be here sin x minus 1 plus cos x. Is that clear now? So here you can cancel this. Cos x will be cancelled, or tan y is equal to, so tan y is equal to, so write down, it is sin x plus 1 minus cos x divided by, in the denominator also you have to write sin x minus 1 plus cos x. Is that clear? So let us simplify it now. You can use the formula from submodel angle, right? So, or this is your tan y is equal to sin x plus, let us keep it within bracket, 1 minus cos x, because you know the formula for 1 minus cos x, isn't it? So 1 minus cos x is kept within bracket, divided by, in the denominator, this is your sin x minus common within bracket 1 minus cos x. Okay, is that clear? Or tan y is equal to what? Let us use the formula here. What is the formula for sin x in terms of submodel angle? You know 1 minus cos x also, isn't it? So what is sin x? It is 2 sin x by 2 cos x by 2 plus, what is 1 minus cos x formula? It is 2 sin square x by 2. It is 2 sin square x by 2, this divided by, what is sin x again out here? It is 2 sin x by 2 cos x by 2 minus, what is 1 minus cos x? It is 2 sin square x by 2, right? It is 2 sin square x by 2. Is that clear now? Now let us simplify it again. Or tan y is equal to, or this is your tan y is equal to, now what is common in the numerator? It is 2 sin x. So within bracket we have cos x by 2 plus sin x by 2 divided by, in the denominator also 2 sin x by 2 is taken common. 2 sin x by 2 is taken common, so within bracket we get, it is cos x by 2 minus sin x by 2, right? So here sin x by 2 gets cancels, or this is your tan y is equal to, this is cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. Is that clear? What's the next? Since this left hand side is in terms of tan y, you have to convert this right hand side in terms of tan again. But these are in terms of cos x by 2 and sin x by 2. So how can you convert it to tan? You have to divide both numerator and the denominator by, cos x by 2. Okay? So if you divide both the numerator and the denominator by cos x by 2, so what do we get? Cos x by 2 upon cos x by 2, 1. Then sin x by 2 divided by cos x by 2 is tan. In the denominator also you can get 1 minus tan x by 2. That means you have to divide both numerator and the denominator by cos x by 2. So, or this is tan y is equal to, it is 1 plus tan x by 2 divided by 1 minus tan x by 2. You know this, isn't it? So this is 1 plus tan x by 2 divided by 1 minus tan x by 2. Now, how will you simplify it further? You can convert it into the form of tan of a plus b compound angle. What is tan of a plus b? Tan a plus tan b divided by 1 minus tan a tan b. Okay? So instead of 1 in the numerator, you write tan pi by 4 plus tan x by 2 divided by 1 minus, there is 1 here. Instead of that 1, you can write tan pi by 4. Okay? So let us write here, or tan y is equal to, instead of 1 in the numerator, you write tan pi by 4 plus tan x by 2 divided by, in the denominator what do we write? 1 minus tan pi by 4 tan x by 2. Okay, tan x by 2 means 1 into tan x by 2, and instead of 1 you write tan pi by 4. Okay, so what is the formula now? Tan of a plus tan of b divided by 1 minus tan a tan b. So this is from common angle. Or tan y is equal to, what is the formula here now? It is tan of a plus b. What is a plus b? Pi by 4 plus x by 2. From both the sides, what can you cancel? Tan will be cancelled. So, or what do we get? Y is equal to pi by 4 plus x by 2. So, this is the simplified form. Now, you can easily differentiate it, isn't it? And you can prove that dy by dx is equal to half. So, differentiating both the sides with respect to x. Therefore, dy by dx is equal to, what is dy by dx of pi by 4? It is 0, you don't have to write it. And what is dy by dx of x by 2? Half is constant, take it outside. Half into dy by dx of x is always 1, that is you will get only half. Is that clear? So it is proved. So dy by dx is equal to half. So this is very, very important question. Okay. So you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 8. If y is equal to tan inverse within bracket a cos x minus b sin x divided by b cos x plus a sin x. This is given so that dy by dx is equal to minus 1. You have to prove the simplified value of dy by dx is equal to minus 1. Okay. So given, so here given is y is equal to tan inverse within bracket, it is a cos x minus b sin x divided by, it is b cos x plus a sin x. Okay. So now in this case you have to use a formula from inverse circular function. Here you cannot do the trigonometric substitution because cos x sin x are already given out there. Okay. So in this case we can use this formula. Tan inverse x minus y upon 1 plus xy. This formula can be used. You know this is from inverse circular function, isn't it? So tan inverse within bracket x minus y upon 1 plus xy. What is this formula? Which is equal to tan inverse x minus tan inverse y. This is the formula, right? So tan inverse within bracket x minus y upon 1 plus xy is equal to tan inverse x minus tan inverse y. You know this formula, isn't it? From inverse circular function. Now, let us convert this expression within bracket in the form x minus y divided by 1 plus xy. So this b cos x should be made 1. That means you have to divide it by b cos x. If you divide this b cos x by b cos x, you should divide a sin x by b cos x. That means we are dividing the denominator by b cos x. That means you have to divide the numerator by b cos x also, isn't it? So you have to divide both the numerator and the denominator by which term? B cos x, right? So or y is equal to tan inverse. So what do we get out here? If we divide both the numerator and the denominator by b cos x, what do we get? You divide the numerator by b cos x also. A cos x divided by b cos x, that is a by b minus b sin x is divided by b cos x, that is tan x, right? So divided by this b cos x is divided by b cos x itself, 1 plus, now it is a by b, and what is sin x by cos x? That is tan x. So we have got this form, isn't it? Instead of x there is a by b, instead of y there is tan x. So this is tan inverse x minus y upon 1 plus xy form. What is the formula? Tan inverse x minus tan inverse y. Okay. So or y is equal to tan inverse, it is a by b minus tan inverse, this is your tan x. Tan inverse tan x. Okay. Now you can differentiate both the sides with respect to x. Now you can easily differentiate it, isn't it? But you can simplify tan inverse tan x. What is tan inverse tan x? That is x. So or y is equal to tan inverse within bracket, this is a by b, right? Then minus, what is tan inverse tan x? This is by formula from inverse circular function, so it is x only, right? So write down differentiating both the sides with respect to x. Differentiating both the sides differentiating both the sides with respect to x, right? So therefore dy by dx is equal to, now what is dy by dx of tan inverse a by b? So it is a constant quantity, isn't it? What is constant quantity? Which is free from x and y. This is known as constant quantity. The quantity which are free from x and y are known as constant quantity. And what is the differentiation of constant quantity? That is always 0. And then minus, what is the differentiation of x? That is 1. So what is 0 minus 1? Minus 1. So or this is your dy by dx is equal to what? It is minus 1. Proved. Understood? So the value for dy by dx is equal to minus 1. Right? So we'll do the next question now. So now we'll do the next question. Question number 9, sorry. It is question number 9. If cos y is equal to x cos of a plus y, prove that dy by dx is equal to cos square a plus y divided by sin a. Now you have to prove that here dy by dx in terms of y. You have to keep in mind that dy by dx should be expressed in terms of y. So you have to express x in terms of y in this case, so that it will be easier for you to prove dy by dx in terms of y. Okay? If you want to prove dy by dx in terms of y, always express x in terms of y. If you want to prove dy by dx in terms of function of y, always express x as a function of y. Right? If you want to prove dy by dx as a function of y, express x as a function of y. Okay? This may be different. This will be different. That's why I have written here f of y and this is phi of y. If you want to prove dy by dx as a function of y, always express x as a function of y. Right? But if you want to prove dy by dx as a function of x, always express y as a function of x. If you want to prove that dy by dx as a function of x, always express y as a function of x. Okay? Now let's do it. Now in this case, you have to express dy by dx as a function of y, isn't it? That means you have to express x as a function of y from given. From given, you have to express x as a function of y. Is that clear? So write down given. Here given is cos y is equal to x cos of a plus y. Right? So in this case, you have to prove dy by dx as a function of y. So express x as a function of y. That means you can easily get the value for x as a function of y. That is cos y divided by cos of a plus y. Right? So let us differentiate both the sides with respect to y. First you find out dx by dy, and you can easily get the value for dy by dx by inverting, isn't it? First you find out dx by dy and get a simplified value of dx by dy, then invert both the sides, you can get the value for dy by dx. Is that clear? Now differentiate both the sides with respect to y now. So differentiating both the sides with respect to y, right? So therefore dx by dy is equal to, which rule is used? You know u by v rule. Y is the variable here. Both the numerator and the denominators are the variable, so you can use u by v rule out here. Okay? Now keep the denominator as it is. It is cos of a plus y into differentiate the numerator with respect to y, because you are differentiating both the sides with respect to y. So what is d by dy of sin y? Into minus sin y, then comes minus sin. Now which function is kept as it is? Now numerator is kept as it is, cos y into Now differentiate the denominator with respect to y. It is just like your cos y, isn't it? What is the differentiation of cos y? It is minus sin y, but here it is minus sine of a plus y, because instead of y there is a plus y. Again differentiate the term which is assumed as y. Which function was assumed as y? A plus y. A plus y is also to be differentiated. Okay, so what is the differentiation of a plus y with respect to y? For a it is 0 plus dy of y is always 1. So into 1. You don't have to write into 1, right? So whole divided by, in the denominator, what do we write? Denominator whole square. What is denominator whole square? It is cos square a plus y. Is that clear to all of you? So now let us simplify it further. Or dy by dx, dy by dx is equal to, it will be plus sign, isn't it? Minus into minus plus. Let us write down this term first. That is sine of a plus y into cos y, then comes plus into minus, minus cos of a plus y into sine y, right? So this whole divided by what? Cos square a plus y. Whole divided by cos square a plus y. Is that clear? Now we can simplify it further. Or dy by dx is equal to, now in the numerator which formula is used? You know the formula? Sin a cos b minus cos a sin b. Here a plus y is taken as a and y is taken as b. So this is sin a cos b minus cos a sin b. What is the formula? Sin of a minus b, right? So it is sin of, what is a minus b? A plus y minus y, that is sin of a minus b, divided by, it is cos square a plus y, right? So let us simplify it now. So here y gets cancels, or, oh, it should be dx by dy, sorry, this is dx by dy, right? This was actually dx by dy, right? This was actually dx by dy, right? Because we were differentiating both the sides with respect to y, isn't it? Okay, so or dx by dy is equal to, what is dx by dy is equal to? This is sin a divided by this y gets cancels, divided by cos square, this is a plus y. Now we can invert both the sides. So inverting both the sides, what do we get? So it is dy by dx is equal to cos square a plus y divided by sin a. So this is the answer, which is equal to right hand side. That means, so inverting both the sides, what do we get? Dy by dx is equal to cos square a plus y divided by sin a. So we got the answer. So it is 2. Is that clear now? So this is your answer. So now we'll do the next question. So now we'll do the next question, that is 17 number 1. It is similar to problem number, just now we did question number 9. This is similar to question number 9. But question number 9 was easier than this 17 number 1, isn't it? But it is similar to question number 9, right? So if sin y is equal to x sin of a plus y, then prove that dy by dx is equal to sin a upon 1 minus 2x cos a plus x square. Now, here in this case you have to prove that, you have to prove dy by dx in terms of x. You have to prove dy by dx in terms of x. Okay? You have to prove dy by dx as a function of x. That means the given part should be expressed as a function of x. That is y as a function of x. Okay? So if you want to prove dy by dx as a function of x, you have to express y as a function of x from the given part. Okay? You want to prove that dy by dx as a function of x out here, isn't it? Because it is given dy by dx is equal to sine a whole divided by 1 minus 2x cos a plus x square. Okay. So if you want to prove dy by dx as a function of x, you have to express y as a function of x from the given part. Okay. So let us write down the given here. So here given is sine y is equal to x sine of a plus y. Okay. Now I already told you that since you have to express dy by dx, you have to prove dy by dx as a function of x, you have to express y as a function of x. You have to express y as a function of x only. On the right hand side there should be only term containing x. On the left hand side you should have the term containing y. Okay. So let's simplify it. So how can you get y as a function of x here? So sine y is equal to x within bracket. You can use the formula of sine of a plus b. In class 11 you did it in compound angle, isn't it? Sine of a plus b. What is the formula for sine of a plus b? It is sine a cos y plus cos a sine y. Bracket closed. Okay. So or this is your sine y is equal to multiply by x here. X sine a cos y plus x cos a sine y. Is that clear? Now keep the terms containing sine y on the left hand side and cos y on the right hand side. Okay, we are simplifying it. Or sine y then x cos a sine y, take it to the left hand side, minus x cos a sine y, which is equal to x sine a cos y, is equal to x sine a cos y. Okay. So what's common out here? It is sine y is taken common. So within bracket, what do we get? 1 minus x cos a is equal to, on the right hand side, it is x sine a cos y. So is that clear to all of you? Now what will you do? Since we are expressing y as a function of x, keep the terms containing y on the left hand side and all of the terms on the right hand side. Okay. So cos y take it to the left hand side and 1 minus x cos a take it to the right hand side. Okay. So what do we get? Or sine y by cos y, sine y by cos y is equal to, what do we get on the right hand side? It is x sine a, this whole divided by, so it is sine y into, now this 1 minus x cos a goes to the right hand side. So when you write 1 minus x cos a on the right hand side, you should write it in the denominator. That is 1 minus x cos a. 1 minus x cos a. Okay. Or what is sine y by cos y? Tan y is equal to x sine a divided by 1 minus x cos a. Is that clear? Now I already told you that whenever you have to prove dy by dx as a function of x, you have to express y as a function of x. Okay. So let us get the value for y from here. So what is y is equal to? It is tan inverse, within bracket, what do we write? X sine a divided by 1 minus x cos a. 1 minus x cos a. Is that clear now? Now you can easily differentiate it. Now we have expressed y as a function of x, isn't it? Now you can easily get the value for dy by dx. Okay. Now write on. Now we can differentiate it. Differentiating both the sides. Differentiating both the sides with respect to x. Now you cannot simplify it further. You can directly differentiate it by taking it as tan inverse x. Okay. So y is equal to, you should take it as tan inverse x. Which function is taken as x? X sine a divided by 1 minus x cos a. Right. So or dy by dx. So what is the differentiation of tan inverse x? It is 1 upon 1 plus x whole square. What is x whole square? X sine a divided by 1 minus x cos a whole square. Right. So this is your 1 upon 1 plus x square. Which function was taken as x? X sin a whole divided by 1 minus x cos a. Again, you have to differentiate the term which is assumed as x. Now in this case, x sin a upon 1 minus x cos a was assumed as x. Again, you have to differentiate this term, that is x sin a divided by 1 minus x cos a. That is, both the numerator and the denominators are the variables here. So we can use u by v rule here, right? So let us use u by v rule, okay? Now denominator is kept as it is, 1 minus x cos a into, what is the differentiation of the numerator with respect to x? You know that sin a is constant. Sin a into d by dx of x. What is d by dx of x? That is always 1. So it remains only sin a. Is that clear? What is the differentiation of the numerator? It is only sin a. Sin a is constant into d by dx of x is always 1. Then write down minus sign. Now keep the numerator as it is, that is x sin a into. Now differentiate the denominator. What is the differentiation of this denominator? For 1 it is 0 and minus x cos a is minus cos a only. Minus cos a, because for 1 it is 0 differentiation and minus cos a is constant into d by dx of x is always 1. So it is minus into minus cos a. So whole divided by, in the denominator what do we write? It is 1 minus x cos a, this is whole square. So here third bracket is closed. Is that clear now? Now let us simplify it. Now we can simplify it further, or it is dy by dx is equal to 1 upon, this is 1 minus, now this square is for both numerator as well as denominator. That is x squared sin square a divided by 1 minus x cos a whole square, right? So we have simplified the numerator, denominator. That is the, we have simplified the second term of the denominator, okay? Into, within the bracket, let us simplify it. 1 into sin a, this is your sin a, then minus x sin a cos a, x sin a cos a, then minus into minus plus, this is also x sin a cos a, x sin a cos a, this whole divided by, in the denominator what do we write? It is 1 minus x cos a whole square. Is that clear now? So here you can cancel this x sin a cos a plus x sin a cos a gets cancels. You can cancel them. So I think you have understood it. Now you can simplify it further now. Or you can take the LCM here. So now, or dy by dx is equal to, what's the LCM? In the denominator, what's the LCM? Now, in the denominator, what's the LCM? 1 minus x cos a whole square is the LCM. So what will be the expression? What will be the expression here now? What will be the expression just above this denominator? Okay. So 1 minus x cos a whole square into 1. That is 1 minus x cos a whole square. Right? Then minus, this is x square sin square a. Right? Into, now within third bracket, so it remains only sin a divided by, in the denominator what do we write? 1 minus x cos a whole square. Here third bracket is closed. So now you can cancel here, 1 minus x cos a whole square gets cancelled. Cancel them. Now you will get the simplified value now, or dy by dx is equal, now it is 1 into, this is 1, isn't it? This was 1. So 1 into sin a. What is 1 into sin a? That is sin a, this whole divided by. Now you can simplify the denominator. We can simplify it. So I think it was plus, I think. Isn't it? 1 upon 1 plus. Yes, it was plus. Okay. So it should be plus sign out there. Okay. So sin A into 1 is sin A. Now simplify A minus B whole square. What is it? A square is 1 minus twice AB. 2x cos A plus what is B square? X square cos square A plus. Now there is x square sin square A. X square sin square A. Is that clear? Now or dy by dx is equal to, this is sin A divided by 1 minus 2x cos A plus, from third and fourth term, what is common out there? It is x square, so within bracket cos square A plus sin square A. Now by formula, what is cos square A plus sin square A? It is always 1. So what do we get? So dy by dx is equal to sin A, this whole divided by 1 minus 2x cos A remains same plus, and you know that cos square A plus sin square A is always 1. So what is x square into 1? That is x square. So it is plus x square. So did we get the result? Sin A divided by 1 minus 2x cos A plus x square. So we have proved it. So it is proved. Is that clear? So this question is very, very important. This question had come in PRHS 2016. Okay, so you can revise the problem at home. So we'll do the next question now. So now we'll do next type of question, that is, it is similar to problem number 9 and 17. Just now we did that problem. Okay, so question number 10 is, if y to the power x is equal to e to the power y minus x, prove that dy by dx is equal to log ey whole square divided by log y. Here also you have to express dy by dx as a function of y. That means you have to express x as a function of y from given part, isn't it? So from given part you have to express x as a function of y. So I think you have understood it. If you want to prove dy by dx as a function of y, you have to express x as a function of y from the given part. Is that clear? So let us write on the given part here. So here given y to the power x is equal to e to the power y minus x. So in this case you have to find out the value for x in terms of y, right? So here in this case you have to take log on both the sides because x should be in the front, right? So taking log on both the sides. So taking log on both the sides. So what do we get? It is log y to the power x is equal to log e to the power y minus x, right? Log e to the power y minus x. Now x becomes the coefficient because there is log. So it is x log y is equal to y minus x into log e. What is the value for log e? If there is no base, the base is e always. And log e base e is always 1. So you don't have to write log e. So x log y is equal to y minus x. Okay. So now I told you that if you want to prove dy by dx as a function of y, you have to express x as a function of y. So you can keep the terms containing x on the left hand side. That is minus x take to the left hand side, or x log y plus x is equal to y. Is that clear now? Now next, take common here. What is common? X within bracket, it is log y plus 1, isn't it? Is equal to y. Or what is x is equal to? It is y divided by, it is log y plus 1. Okay? Now let us find out the value for dx by dy. That means you differentiate both the sides with respect to y. You first find out dx by dy, simplify it, and then inverting both the sides, you can get the value for dy by dx. Okay? So differentiating both the sides with respect to y. Right? So therefore dx by dy is equal to, which rule is used? U by v, isn't it? So denominator is kept as it is, you know u by v rule, log y plus 1 is kept as it is into, what is d by dy of y, where we are differentiating y with respect to y, that is 1, minus y is kept as it is into, differentiate the denominator with respect to y. What is d by dy of log y plus 1? Log y, it is 1 by y plus 0. And 1 by y plus 0 is always 1 by y. Whole divided by, what do we write here? Log y plus 1 whole square. Is that clear? Now let us simplify it now. Or dx by dy is equal to 1 into log y plus 1 is log y plus 1. Then here y gets cancelled, so we get minus 1 whole divided by, this is log y plus 1 whole square. Is that clear? So here 1 gets cancels. So or it is dx by dy is equal to log y divided by log y plus 1 whole square. So since we have to prove log ey whole square divided by log y, this is not the base e. It is just like your log AB, right? It is just like your log AB. So this e is not the base of the logarithm. Okay? So now how will you prove it? Now you can invert both the sides. So inverting both the sides, what do we get? Dy by dx is equal to, it is log y plus 1 whole square divided by log y. That means we are inverting both the sides. Now how will you prove the required result? Now instead of 1 you write log e, okay, or dy by dx is equal to log y is there, isn't it? Plus instead of 1 you write log e plus log e bracket closed whole square divided by what? It is log y. Is that clear to all of you? Now within whole square, this is log a plus log b form. What is log a plus log b? It is log of ab, right? So or now we can write dy by dx is equal to log ey whole square divided by log y. That is log y plus log e, just like your log a plus log b, which is equal to log of ab. Similarly, log y plus log e, if you use that properties of logarithm, it will be log ey whole square divided by log y. So it is proved. So this is also very, very important question, right? So now we'll do the next question. You can copy it. So now we'll do the next question, that is element number 1. Before that, this is your homework, right? If x to the power y is equal to e to the power x minus y, prove that dy by dx is equal to log x divided by log ex whole square. It is similar to problem number just now we did, that is problem number 10, isn't it? We did just now problem number 10. It is same as problem number 10. I will not give you the hint now. Okay? Do it yourself. Prove that dy by dx is equal to log x divided by log ex whole square in the denominator. Okay? So let's do question number 11.1. So what is given out here? It is given if y is equal to x by 2 root under x square minus a square by 2 log of x plus root under x square minus a square, so that you have to prove that dy by dx is equal to root over x square minus a square. So let us write down the given. Your given is y is equal to x by 2 root over x square minus a square by 2 is constant here, log of within bracket x plus root over x square minus a square. Now let us differentiate both the sides with respect to x. You have to prove the value for dy by dx, right? So differentiating both the sides. So differentiating both the sides with respect to x, okay? So therefore dy by dx is equal to half is constant out here. It is taken outside. Then within third bracket you have to differentiate x root under x square minus a square. This is the product rule, isn't it? UV rule. You know UV rule? Let us keep x as it is into, now differentiate within square root x square minus a square. It is just like your root over x. What is this differentiation? 1 upon 2 root over x square minus a square into, now differentiate the term which was assumed as x. That is, you have to differentiate x square minus a square which is assumed as x. So what is this differentiation with respect to x? It is 2x, right? Is that understood now? Plus, now which function is kept as it is? Now root over x square minus a square remains as it is into. What is d by dx of x? That is 1. You don't have to write 1. Okay? So here third bracket is closed. Is that clear? Then minus second term. You have to differentiate the second term. Minus a square by 2 is constant into, what is the differentiation of log of x plus root under x square minus a square? That is, it is in the form of log x. What is the differentiation of log x? 1 upon x plus root over x square minus a square into, again differentiate the term which is assumed as x. In this case, x plus root under x square minus a square was assumed as x. Now we have to differentiate it. Okay? So within third bracket you differentiate this term. What is the differentiation of x? 1 plus, again what is the differentiation of root over x square minus a square? You should take it as root x. So what is the differentiation? 1 upon 2 root over x square minus a square into, now differentiate the term which is assumed as x. In this case, x square minus a square was assumed as x. So what is this differentiation? It is only 2x minus, what is the differentiation of a square? A square is constant, so its differentiation is always 0. So here third bracket is closed. Is that clear? So here you can cancel this 2. Here also you can cancel this 2. Or let us simplify it now. So dy by dx is equal to half within third bracket. X into x is x square divided by x square minus a square, right? Then plus this one is root under x square minus a square. Is that clear? Then minus a square into 1. A square divided by, in the denominator what is here? It is 2 within bracket x plus root over x square minus a square into, so what's the LCM out here? So what's the LCM now? So what's the LCM here now? The LCM is root over x square minus a square is the LCM, right? So what will be there in the numerator? It is root over x square minus a square plus x. So here third bracket is closed. So I think you have understood it. Now here you can cancel these two terms, isn't it? These are similar terms. Similar terms can be cancelled. Now let us simplify it. So let us simplify it now. Or dy by dx is equal to, it is half within third bracket. What's the LCM now? Here it is root over x square minus a square is the LCM, and below this root over x square minus a square there is 1, so its LCM is root over x square minus a square. So this LCM is divided by root over x square minus a square. It is 1. So 1 into x square is x square plus, now this LCM, root over x square minus a square is divided by 1. That means root over x square minus a square. Now multiply it again by root over x square minus a square. What do we get? It is x square minus a square, right? Root over x square minus a square into root over x square minus a square is equal to root over whole square. So root over will be cancelled, so you get x square minus a square. So here third bracket is closed. What is the next one? Minus a square divided by, this is your 2 root over x square minus a square. Clear? Now let us simplify it. So let us simplify it now. Or dy by dx is equal to, this is 2x square minus a square divided by 2 root over x square minus a square, then minus, so this is your a square divided by 2 root over x square minus a square. Is that clear? Now take the LCM. What's the LCM? Or dy by dx is equal to, what's the LCM out here? It is 2 root over x square minus a square is the LCM, because both are same. So this is the LCM. Now this LCM is divided by this factor, that means 1. So 1 into 2x square minus a square is 2x square minus a square minus, again this LCM is divided by this denominator, that is also 1 into a square minus a square. Is that clear? So or dy by dx, let us write it out here. Right? So what is dy by dx now? So dy by dx is equal to 2x square. So minus a square, same sign can be added. Minus 2a square divided by, in the denominator, 2 root over x square minus a square. Okay? Now we can easily simplify it. What is common here? Or dy by dx is equal to 2 is common here. X square minus a square divided by, in the denominator, what do we write? It is 2 root over x square minus a square. So you can cancel it. So 2 gets cancels. Now root over. Now x square minus a square will be cancelled by root over x square minus a square. So it goes how many times? Root over x square minus a square. So root over x square minus a square divided by root over x square minus a square is 1. And x square minus a square can be cancelled by root over x square minus a square, which goes root over x square minus a square times. Okay. So what is the final answer? Or dy by dx is equal to, what is the answer here now? It is root over x square minus a square. So which is proved. That is dy by dx is equal to, within square root, it is x square minus a square. So we have proved it. Is that clear to all of you? So you can copy it. So this much is for today. So your homework will be the revision. You revise all the problems that we did today. Okay. So this much is for today. So in the next class we'll do more problems. Okay.